Yes, good morning, everyone. Today, we will understand the application of ARMA modeling. So, as far as this modeling is concerned, this model is used to do predictions based upon the past data. So, imagine that you are trying to predict what will be the price of a particular stock tomorrow, or what will be the demand of electricity next month, or what will be the temperature because of global warming in the upcoming years. So, at first glance, it looks like chaos because if I'm talking about the share price, n number of data will be available. If I'm talking about daily share price, every day prices goes up, prices goes down, and this going up and down is random in nature. But understand, here is the secret behind this apparent randomness. So there is a hidden pattern in these fluctuations which are happening. And if we are able to identify these patterns, then definitely prediction will be easy to do. So ARMA modeling basically a way of making the prediction based upon the past data that is available to us. So if we look at the full form of ARMA, AR refers to autoregressive, MA refers to moving average. So as far as autoregressive is concerned, autoregressive essentially means that my past values is acting as independent variable and my current value is acting as dependent variable. For example, if I'm willing to do prediction on the share price of Reliance Industries, whatever was the share price of Reliance Industry yesterday, that is going to determine what will be the share price of Reliance Industry today. Are you getting my point? From the past value, I'm trying to predict the future value. Then whatever prediction I am doing, there can be error in that particular prediction. Yes or no? There can be difference in the actual value and predicted value. So the pattern of that error is also need to be identified. That pattern is nothing but moving average. So moving average is making predictions more accurate by studying the pattern in the error that we are not able to predict. So autoregressive basically means that I am applying regression analysis, and in that regression analysis, my dependent variable is today's value of Reliance Industries, and my independent variable will be the past value of Reliance Industries. It means with the help of past value, I will be trying to make a prediction on the today's value. Moving average means that whatever prediction I will be making, definitely there will be an error. On the basis of pattern of that error, also I will be trying to make my prediction more refined, to make my prediction more right. So, in this combination, there will be a predictive model that will be defined. So, ARMA modeling is basically like driving a car. So, when you drive a car, you look back into the mirror, and on the basis of it, how the vehicle that is previous to me is driving, I try to predict that how it is going to cross me in future. I try to predict the behavior of the vehicle by looking into the mirror. Now, that prediction will determine how I will drive, but definitely, again, in my prediction, there can be error. My car can drift because of the slippery road. Now, since my car drifted, I will drive in a certain way in upcoming time. So, looking back into the mirror is like auto-regressive. You can see the diagram here. Looking back into the mirror is like auto-regressive, and because the drift refers to error here. Because of the error, I will be driving in a certain way. Because of looking at back into the mirror, I will be driving in a certain way. So looking back into the mirror is autoregressive, and driving in a certain way because of error is moving average. So by combining these two mathematical concepts, prediction will be done. Now, how prediction is done? There is a specific way to that. For the purpose of making prediction, it is necessary that data should be stationary. Data has to be stationary because if data is not stationary, then ARMA model cannot be applied. So considering stationarity, we need to understand stationarity means that there is a specific pattern in the data. Stationarity can be checked at level. It can be checked at first difference. It can be checked at second difference. Stationarity means that over the period of time, three things are constant. One is average, another is variance, and the third thing is autocorrelation. So if over the period of time these three things are constant, we are calling the data stationary. What stationarity actually is, we will be looking in any other lecture. But for the time being, if the data is stationary, autoregressive moving average can be applied. If data is not stationary, then make it stationary. Fine. We can make it stationary by taking the first difference. We can make it stationary by making the second difference. If data is stationary, ARMA, autoregressive moving average, will be applied. If data is not stationary, that is at first difference data is coming to be stationary, at second difference data is coming to be stationary, then we will apply ARIMA, autoregressive integrated moving average. So depending upon the results, a particular tool will be applied. Now let us see the practical application of the tool. Yes, so I will go to Google and I will type Reliance data BSc. And if I scroll down, I will be able to see Reliance Industries Limited BSc here. I will click here. I will go to official website of BSc. On the right hand side, you can see archives is written. I will click on archives, and here, depending upon what is the objective of your research, you can select daily data, monthly data, yearly data. Right now, I will be dealing with the daily data. Let me change the year. For the time being, I am taking random year here. Okay. I will submit it. The data for the given dates will be loaded. Down there, you can see the option to download a short blue color icon. Click on this short blue color icon. Excel file will be downloaded. Open this Excel file. Once this Excel file is opened, different kind of variables are given to you. I'm not concerned with open price, high price, low price, closing price. I'm only concerned with the last column. So I will delete all this. Last column essentially is the spread. That is closing value minus opening value. It is the return from the share market if you are doing intraday trading. Fine. So let me change the name and let me write here Reliance return. I will save this file. Yes, I think the application was not shared. Let me show you again. This was the original sheet that was downloaded. So in this original sheet, all these variables are not relevant to me for the time being. I'm only concerned with the last column. So let me delete all this. So this is the spread. Spread means closing value minus opening value. Closing value is what was the value when market closed in the evening. Opening value is what was the value when market opened in the morning. So if you are doing intraday trading, it refers to the returns. So somewhere you can see negative value, somewhere you can see positive value. Negative value means you incurred a loss. Positive value means you suffered a profit by doing intraday trading into the share of Reliance Industry. Let me change the name Reliance Return. Let me save it and close it down. Now again, Let me share the file with you. Yes, again, we will go to Google. Now there are different softwares running ARMA modeling. For the time being, I will be applying Google Colab. So I'm opening Google Colab. Let me open the new worksheet from here. New notebook in Drive. Once new notebook is open, here you can see that a small icon of plus is there. I will click on plus. I will click on upload file. And then I will be selecting the file that is recently downloaded. Okay, the file is uploaded. So I have told you for the application of ARMA modeling, data need to be stationary. So let me check stationary. I will write the prompt. Check stationarity by applying ADF test at level, at first difference, and at second difference, and show results in table. Then I will give the prompt. Now, the file that is being uploaded, this will analyze it, and I will click on accept auto run. Now, all these steps will be performed automatically by Google Colab, and in some time, we will have the results. The best thing about this Google Colab is that it give the interpretation of the tables as well. So we will have the data and we will have the interpretation of that data that will be useful for us in making different kind of judgments about the data which is available. So let us wait for some time and complete this entire operation. Yes, the results are ready. Let me cross it. And here you can see that different coding has been automatically initiated by the software. And let me see that whether data is stationary at level, at first difference, or at second difference. So here you can see a table is there. Data at level is given to you. Data at first difference is given to you, and data at second difference is given to you. So at level, you can see p value is less than 0.05. Yes. Is it readable for you? At level, the p value, this is the p value, it is less than 0.05. And since it is less than 0.05, it means data is stationary at level. And let me tell you that if data is stationary at level, it will be stationary at first difference also. It will be stationary at second difference also, but I will be giving the preference to the first level of stationarity. So in first level of stationarity, data is stationary at level. Sometimes data will not be stationary at level. It will be stationary at first difference. So I will be applying ARMA, AutoRegressive Integrated Moving Average. Right now, data is stationary at level, so I will be applying ARMA, that is AutoRegressive Moving Average. So I will click here, apply ARMA model, and make all relevant tables and diagrams. Then I will run this model. Again, it will take some time. For the purpose of completion of analysis, I will click on accept and auto run and wait for the software to check whether model is fit for making the prediction of share of Reliance Industries. Till the time we are having the results, remember, auto-regressive moving average is making prediction based on two parameters. First is what was the value of share in past, that is auto-regressive. Second is what was value of error, that is moving average. So it is a model of prediction that combines past values and the errors in prediction. Let us wait for the results to get complete. It has skipped one step, as you can see here. Forecast future values. Fine, we will do it some other time. Let us have an assessment of the results that we have received. So you can see the first diagram that is shown is autocorrelation function ACF. I have told you in the beginning, data must be stationary. What is the meaning of stationarity? Three things are constant over time. One is average, second is variance, third is autocorrelation. So you can see that autocorrelation is constant over time. Partial autocorrelation is also constant over time. So definitely ARMA model should be a good fit. Let us check that ARMA model is fitting properly here or not. So you can see data is there with you. Yes, here you have the results of ARMA model. Okay. So all these starting from here till here are the results of ARMA modeling. Let us try to understand what all these things means. So when you will look at the result on the left hand side, on the left column, you can have an assessment that different things are written, and also their significance level can be determined with the help of p value. So we will try to make a prediction that whether ARMA modeling can be used for making the prediction of Reliance Industries or not. So first thing is constant. You know the regression equation y is equal to alpha plus beta x. So this beta is constant. Fine. A simple regression equation. This constant is the value of beta. And if you look at the p value, it is not statistically significant because it is more than the threshold limit of 0.05. Next is AR, autoregressive lag 1. Autoregressive lag 1 means that lag 1 means previous day value. Fine. So past value. So if you look at autoregressive lag 1, yes, it is statistically significant. Moving average means error. Yes, error. The value of error is also statistically significant because the value is less than 0.05. Then in last, you have the value of sigma square. Fine, sigma square is also statistically significant. So again, we can make interpretation based upon it. So out of four parameters, constant, AR, MA, and sigma square, one is not statistically significant, three are statistically significant. So we can say that yes, model is a good fit. Moreover, the presence of past day value is having a significant influence on today's value, and the value of error is also having a significant influence on today's value. Both of these are statistically significant. So these are the AR and MA are the major parameters of decision making, that whether we can use this for the purpose of making judgments regarding a particular data or not. Okay, first of all, let us understand what is the value of sigma square. Sigma square is the variance of residuals. Residual means something which are outside the purview of prediction. So the variance of that is calculated, and the variance is also statistically significant. In By looking at this value, we can make an interpretation that yes, variance of residual returns are quite volatile. So the shares of returns, Reliance Industry is volatile in nature. It means a reasonable level of fluctuations can be seen. All these values are not relevant for us for the purpose of making interpretation, but still, if you want to write something about it, while interpreting it, you can write that the p value of L junk box is, the z value is 0.06. So, and the p value here of it is not given. Okay, probability is given. Probability is 0.8. So you can see that it is more than 0.05. So it means residuals are not autocorrelated. So it is good. Fine. If residuals are autocorrelated, then it is not a good factor. So right now, there is no significant impact of residuals. So residuals are not autocorrelated. It is a good thing. And if you look at the value of Jarque-Bera, the probability is less than 0.05. It means residuals are not normally distributed. Normally, it is considered bad. But let me tell you, it is common for the stock return. Jarque-Bera test is a test for normality. If normality is there, we will say it's very good. But if normality is not there, we will say, see, normality is not there, but still it is acceptable because it is very common in stock return. It is like a jewelry. Fine. If jewelry is there, it will look good. If ornaments are there, it will look good. But if it is not there, it hardly makes any difference. Only there is a difference in how a particular thing is looking. Fine. And looks does not matter. It has a only role of perception. Moving ahead, we have the value of heteroscedasticity, and the probability again is less than 0.05. So heteroscedasticity means, and having a p value of less than 0.05 means variance is not constant. It means volatility clusters exist. So again, it is a bad sign, but yes, of course, it can be avoided. And it is suggested whenever there is heteroscedasticity, instead of applying ARMA model, you can apply Garch model in it. Okay, general autoregressive conditional heteroscedasticity. So right now, Garch will be a topic of any other class, but yes, for the time being, it is not a good sign, but in we can avoid it because we are having this AR value statistically significant, MA value also statistically significant. Then you have the value of skewness and kurtosis. So it is slightly more downside. There are negative returns more and positive returns less. So that's why it is negative. Then kurtosis value is also there with you 10.37. So it represents heavy tails. It means extreme movements much more likely than normal distribution. So extremes up and down can be witnessed here. Let us, I have told you the best thing about this is that it also gives us the interpretation. The graph of residuals are also given to us. We will copy paste all these tables, all these graphs into our Word file for the purpose of data analysis. Yes, you can see a time series, original and fitted values. That red color lines represent the fitted value and blue color lines are the original returns of the data. So you can see that we are able to fit our prediction within the limits of the actual value. So we are able to do the prediction pretty much good with the help of ARMA modeling. So here we can see the analysis of ACF and PACF plot might be appropriate for the time series data and ARMA 11 model specified ARMA 101. Yes. Okay, insights. While ARMA 11 model appears to fit the historical data well and the residuals are uncorrelated, further diagnostic check, for example, residual heteroscedasticity, could provide a comprehensive evaluation of the model assumption. I have already told you that heteroscedasticity is not there, but yes, the good thing is, okay, normality is also not there, but the good thing is that residuals are uncorrelated. Fine. This interpretation we have already made with the help of L-Jung box test. Jarkebera says that normality is not there. Fine. And then we have the heteroscedasticity test, which tells us that variance is not constant, volatility clustering do exist. So it is advised. I am telling you that Garch model will be applied in that case, that we will apply anytime else. However, if you want to apply, just give the command apply Garch model. How to interpret the results, that we will see in the upcoming time. Fine. So this is how ARMA model is applied, and this is how you interpret the different terms related to autoregressive moving average. So what you are supposed to do, depending upon the kind of variable you are dealing with, you might be dealing with the variable of green cryptocurrency. So on Google, you can write down green crypto, or you can write Bitcoin data or BitGreen data. BitGreen is the green version of cryptocurrency. BitGreen data, NAS, DOQ, DAQ, NASDAQ, and you will press enter. BitGreen historical data. Yes, so here you have historical data. So from the website of NASDAQ, yes, here you have. So 1 month data is available, 6 month data is available, 1 year data is available, 5 year data is available. All the data from the very much beginning is available. So whatever is the objective of research, click on that particular thing and then you can click on download historical data. File will be downloaded. If you are dealing with any economic indicator, so for example, you are applying ARMA model on GDP, you will write GDP data World Bank, enter, click here. A file will open. Again, when you will go down, you can see the option to download. You can download CSV file, you can download Excel file, click on the Excel file, and the data of entire world will be downloaded. You can apply the filter of your particular country. If you are doing research on BRICS nation, you can apply filter of BRICS nation, apply ARMA modeling, and tell that where prediction is more possible as far as BRICS nations are concerned, as far as SAARC nations are concerned. This is how you can apply, and you can make interpretation on the various parameters. So anything which can be projected in time series data, we can make prediction based upon it. Fine. And on the basis of those predictions, we can decide our future course of action. So that's all for today's lecture. We have learned how autoregressive moving average is applied. I hope everything is clear. Apply it yourself, interpret it, and definitely make sure that you prepare your article within prescribed amount of time. See you in the next class.